All right, so we're going to go ahead and look at these notes right here. First thing we have here on our warm-up is it says that the figure gives a circle of radius 4.8 in the xy plane with center at the origin, an angle alpha in standard position, and 3 labeled points, which the following is the value of sine alpha. So what I'm looking for right here is I'm just trying to figure out what is sine of this angle right here. I can see right here that I have that small little angle. So what I'm going to do here is these values that are given me here for my x and y, they are not on my unit circle. And so what I'm going to do is I'm going to go ahead and just drop a straight line from there down to my x-axis. And now I have a triangle. The horizontal is that 2.2 right there, and the vertical is 4.3. The other information that I could solve, given that information, is for my hypotenuse using Pythagorean theorem, but I don't need to do that because it tells me that I have a circle with a radius of 4.1. If I notice right here between this point 0 and this point A, that's my radius. So this is 4.8. So now in order to solve for sine of my alpha, I just do SOHCAHTOA, which is opposite over hypotenuse, which would be 4.3 divided by 4.8, which happens to be this value right here. I would also double check and make sure that none of the other answers are a possible choice, and none of them are. A common mistake here would be going ahead and selecting 4.3 or option D here as what is your sine value, simply because we have learned that our y coordinate on our on our unit circle is our sine value, right? We know that x is cosine, y is sine. And so if we do that, then we have a radius of 1. This one has a radius of 4.8, so I can't just do whatever is the y value because it's only when the radius is 1. Okay, so looking here, in order to do these problems right here, we have to have some basic information that has to already be known. This information that is right here, I just need you guys to be very aware that these questions 1 through 9, you are going to have a bunch of quick quizzes. There's going to be 8 10-minute, 10-question, rapid fire quizzes that you're going to have over the next month. So understanding how to do this is very important. So in order to answer any of these questions, it's wanting me to give an exact value for these various different trig functions. So in order to answer any of these, the very first thing that I must have is some basic information that I need from background information. One of those things that I need to know is that I have a coordinate point of x and y on my unit circle, and that's going to give me my x is my cosine, and my y is my sine of whatever that angle is. I should also know that tangent is the exact same thing as taking my sine value and dividing it by my cosine value. That's also the same thing as saying it's y over x, or also your slope. We've discussed that. The other thing that we should know is we know SOHCAHTOA, right? We've all known that for a long time, but our new ones that we learned just yesterday is that we have our cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So we need to know those. And then the last thing that we need is what is our first quadrant of our unit circle. So if I look for just my first quadrant, so essentially what you did on your memorization quiz, I need to know that this is 0 radians, pi over 6 radians, pi over 4 radians, pi over 3 radians, and pi over 2 radians. We also need to know what their coordinate points are, that this one is at 1, 0. This one is going to be square root 3 over 2 and 1/2. Pi over 4 is square root 2 over 2 and square root 2 over 2. Pi over 3 is going to go ahead and get me 1/2 and square root 3 over 2. And then pi over 2 is going to get me 0, 1. Those are my coordinates, which also tell me what cosine and sine are. The next bit of information I need is what is their slope or their tangent. We know right here that's going to be 0. Here we're going to have square root 3 over 3. At pi over 4 we have 1. Pi over 3 is just square root 3. And at pi over 2 it is undefined. Okay. We need all of this information in order to answer these questions. Do I need all of it for each one? No, but in order to answer these types of questions, I need this stuff. All right, so if we go over here and look at these questions, the first thing I have here is that sine pi over 3. So I need to know what is the exact value of sine pi over 3. Well, I could put that in my calculator and I could just do, okay, I've got sine pi over, I hit the wrong button, sine pi over 3. But that gives me back 0.8660254,038, and it keeps going. That's not what I need. I need the exact value. No decimals, exact. So if I was to do that, I would have to look at my unit circle and find pi over 3, which is going to be right here. And I need to know what is the y coordinate that I'm given, which is pi over 3. Or I'm sorry, root 3 over 2. Okay, so that's what I've got. So that's my answer. I just do, this is square root 3 divided by 2. And you can see that by if you take this, and I could go ahead and I could put square root 3 divided by 2 in the calculator, and those are the exact same decimals, okay? So my exact value for what is sine pi over 3, it is square root 3 over 2, okay? I'm going to skip the next one really quick for just a second, and I'm going to come back to that. We're going to do tangent 3 pi over 4. Well, 3 pi over 4 is not in my first quadrant, so I don't have the radian measure right here in front of me, but I can figure out which quadrant it's in. If it's 3 pi over 4, the way that I always do these is I go, okay, so I take what I'm dividing by, so that 4, my denominator, and I turn this into 4 pi over 4. And I turn this into 8 pi over 4. The reason I do that is because 4 pi over 4 is equivalent to pi, and 8 pi over 4 is equivalent to 2 pi. And now I can kind of look at what I have in relation to what I need. So here I would also go ahead and figure out what my axes are, and halfway between 0 and 4 is 2 pi over 4, and halfway between 4 and 8 would be 6 pi over 4. So I can clearly see 3 pi over 4 is going to be right between 2 pi over 4 and 4 pi over 4. So I can see that that is going to get me in my second quadrant right here. And I've got this angle measure right here, going from my standard position, which is my positive x-axis, to that angle. Okay, so I can go ahead and go, all right, so if this is my angle that I've got right here, I know that sine over cosine gets me tangent, but that means that I need to know what this x value and this y value are right here. Well, we can look at our unit circle that we have right here, and I have an x value in my second quadrant. If it's in my second quadrant, I know that cosine is negative, and I know that sine is positive. So I know I'm going to get a negative number back for my tangent. So this is going to get me some negative number. Well, this angle right here for this triangle, this triangle right here, for this little angle would be the same thing as pi over 4, right? So if I come over here and think about what I've got right there, these are the same exact angles, right? That's going to get me pi over 4, which is exactly what I need. Why is this erasing everything? Okay. So really what I have right here is the same exact value as what I would have for pi over 4. It's just negative. So my tangent for pi over 4 is 1. So my tangent for 3 pi over 4 is negative 1. And I can even look at an entire unit circle, and I can see that right here. If I look at the whole entire thing, you can see right here for 135 at 3 pi over 4, it's just square root 2 over 2 divided by negative square root 2 over 2. Well, that's a number divided by its negative number. So anything divided by itself is 1. So this is just negative 1. If you notice, when I'm going through this entire unit circle, all of these values that I have here, my x values and my y values correspond with their reference angle. So the reference angle is that small acute angle between the terminal side of the angle and my x-axis. So 5 pi over 6, for example, its reference angle is pi over 6. Same thing, I have 4 pi over 3 down here. Its reference angle is pi over 3. So once I know whether or not it's positive or negative for an x coordinate or a y coordinate because of the quadrant that it's in, all I need to know is what is the x or the y coordinate in the first quadrant. So what I'm going to do here for this one, it's just negative 1. If I come down here and I do cosine 5 pi over 3. So now I need to know 5 pi over 3. I've got to figure out which quadrant is 5 pi over 3 going to be in. I mean, it's on my unit circle, and if I have my entire unit circle memorized, then I'm fine. I know exactly where it is. But if I don't know where my unit circle is, and I got 5 pi over 3, again, I take my denominator and turn this into 3 pi over 3, and I turn this into 6 pi over 3. So again, this reduces down to pi, and this one over here reduces down to 2. Then I've got to figure out halfway in between each one of those. So halfway between 0 and 3 is 1.5 pi over 3. And halfway between 3 and 6 would be 4.5 pi over 3. So now I can look at that and go, okay, so this needs 5 pi over 3. So 5 pi over 3 is greater than 4.5, but less than 6. So it's going to be over here in my fourth quadrant. So I've got this right here. So in my fourth quadrant, we know that my cosine is positive and my sine is negative. So what is this asking for? It's asking for cosine 5 pi over 3. So I'm going to have a positive value back. My reference angle for 5 pi over 3 is equivalent to pi over 3. So if I come up here and look at my cosine at pi over 3, it's 1/2. So this equals 1/2. Okay. I'm going to skip all of my reciprocal ones for right now, and I'm just going to do 7, 8, and 9, and I'll come back to 2, 5, and 6. So 7 is tangent negative pi over 3. So let's recall that positive angles go counterclockwise and negative angles go clockwise. So if I was to do this, I would, instead of having what I have right here, I would instead go the opposite direction. So instead of going up, sorry, I accidentally deleted these. So instead of going up to pi over 3, I would go down the same exact distance. So that puts me in my fourth quadrant, doesn't it? So what I'm going to do here is I'm going to go, okay, I'm in my fourth quadrant. My little sketch, if I need to, is right here. So this is my angle measure. It's the same thing as having pi over 3. And so I just need to know, what is tangent at pi over 3? Well, tangent at pi over 3, what we have over here is it's square root 3. All right, so this is going to get me square root 3, except since it's in my fourth quadrant, sine is negative, cosine is positive. So a negative divided by a positive gets me a negative number. Okay. Sine 3 pi over 2. Well, 3 pi over 2 is straight down on my unit circle. It is my negative y-axis. So sine is going to get me negative 1. And cosine is equivalent to 180 degrees. It's my negative x-axis. And that's also going to get me negative 1. Now I've got to do my reciprocals. My reciprocals are going to go ahead and get me, I've got secant, cotangent, and cosecant. So the easiest way to do this, in my opinion, is I go secant, so I need to find cosine. I need to know what is cosine 5 pi over 6, and then I flip it. So what I'm going to do is I'm going to go ahead and come over here. I've got cosine 5 pi over 6. 5 pi over 6 gets me right here in my second quadrant. And so I'm looking at this angle, which is going to go ahead and get me a reference angle of pi over 6 in my first quadrant. So I'm going to look at these values right here for pi over 6. I have square root 3 over 2 and 1/2. And again, this is wanting cosine. So cosine at pi over 6 is square root 3 over 2. So I'm going to have cosine pi over 6 is square root 3 over 2, but 5 pi over 6 is going to be negative square root 3 over 2. That's for cosine. I need secant, don't I? Actually, I'm going to not take up so much space. So I have cosine 5 pi over 6 is equal to negative square root 3 over 2. So to do its reciprocal, I have negative 2 over square root 3. Except I have to rationalize that. So I'm going to multiply top and bottom by square root 3. And that gets me negative 2 square root 3 over 3. Cotangent pi over 2 is a little bit tricky because if we look at tangent at pi over 2, tangent at pi over 2 is undefined. While tangent is the same thing as sine over cosine, cotangent isn't, it is the reciprocal of tangent, but it's the same thing as doing cotangent, is the same thing as cosine over sine. Okay, that's easier. If I look at pi over 2 and I do cosine divided by sine, I get 0 divided by 1. So if I come back over here, I have this is equal to 0 over 1, which is 0. My last one that I need to do is cosecant 7 pi over 6. So if I'm doing that one, okay, I've got to figure out which quadrant I'm in, and it's going to be here. I'm going to be in quadrant 4. 7 pi over 6 is just greater than 6 pi over 6. So I'm going to be in that quadrant. So cosecant is the reciprocal of sine. So my third quadrant is my sine positive or negative. It's negative. So I'm going to have a negative value there. 7 pi over 6 gets me the same angle as pi over 6. So I'm going to come back over here and I'm going to go, okay, pi over 6 for sine is 1/2. So this one for sine would be -1/2. So that means that its reciprocal for cosecant is just -2. Okay? So that gets me through these questions. Like I said, you're going to have a quiz on those. You're going to have 8 of them, actually. One is a practice, and then we will take your best 5 out of the 7 that count. Okay? I'm going to do the next questions in a separate video. So if you have questions on these, let me know.